recording. So this is going to be recorded so we can share it with folks who weren't able to join us today, which we do with all of our Pacific Northwest Forest Collaborative online workshop series. So good afternoon, everybody, and thank you for joining us. This is Sustainable Northwest Pacific Northwest Forest Collaborative workshop series, which we're doing virtually again this year. This specific session is focusing on monitoring and adaptive management, and it's highlighting a case study in the Southern Blues, which is Northeastern Oregon. So for those of you who've joined in the past minute or so, if you could take a moment and introduce yourself in the chat box, just your name, your organization, and the location where you're coming from today. This is the second year of Sustainable Northwest hosting the annual event virtually. Hopefully some of you remember we were gathering in person in Hood River for the past many years. There will be similar series of workshops across the summer like we did last year. So at least once a month, sometimes more. And they'll be lasting through October. So thanks to everybody who joined us for the last workshop, which was enhancing tribal partnerships. That recording is now available on our website if you missed it and you'd like to see it, or if you attended and you'd like to view it again. And you should have received a link to that when you signed up for this. It was in the announcement. But if you need that, please feel free to contact myself, Trent Sager at Sustainable Northwest, or Sally Bernstein, who's moderating the series this summer. I'd like to share my screen here and so I can thank our sponsors. So thanks to the sponsors for the P&W workshop, which is Oregon Prescribed Fire Council, Citrine Advisors, First Interstate Bank, Thai Oregon, Ochiko Lumber, Northwest Fire Science Consortium, Greenwood Resources, the Forest Service, Hampton Lumber, Investors Management Group, City of Roses, Tillamook, Port Blakely, Timberline, Coca-Cola, and project. So thank you to our sponsors. And just to go over some basic ground rules, and due to the bandwidth and the number of people attending, we're going to ask people to stay muted unless otherwise instructed, and also to have your cameras off to decrease the bandwidth while the panel is presenting. You can use the chat box to ask questions. Those questions will come to me as the host, and then I'll pool the ones that are similar and share those with James, who's our panel lead and moderator today, and he can ask those to the panel. And anybody who's spamming or breaks those rules will be kicked off. Here we go. And finally, I would like to hand this over to Dr. James Johnston from Oregon State University College of Forestry, and also Blue Mountains Forest Partners, who will be our panel lead today. And James, I've given you co-host capabilities, so you should be able to share your screen.
I thought that I was prepared, but I seem to have lost something here. Oh, there it is. So why doesn't somebody confirm to me that they can see this slide and we'll get started?
There you go. It's good. You're good to go, James.
Okay, you can see my...
Sorry, James. I will just ask everyone who's not presenting to kill their video feed so we don't eat up the bandwidth. Thank you.
All right. Hey, everybody. My name's James Johnston. I have, for more than 10 years, been working very closely with the Blue Mountains Forest Partners. I'm a research associate. I'm an ecologist with Oregon State University. I'm coming to you this afternoon from my backyard in South Corvallis. I don't know about you, but I have become so informal about Zooms. I don't know what's going to become of me once I have to return to civilization. for starters, I think I'm going to have to buy some new shirts or something. Anyway, I'm absolutely delighted to be here today to see so many old faces and some new folks that I haven't met yet. I'm always super eager to talk about monitoring and adaptive management, and would love it if folks would contact me via email through Sustainable Northwest, or hopefully at some point I can share my email with folks through the chat box. Let's stay in touch about monitoring. There's just enormous value to being able to collaborate and talk to one another, those of us who are working in the monitoring business. And I'm joined also by Susan Jane Brown, Mark Webb. I don't know if Pam Hardy was able to make it, Dave Hannibal. These are the folks that are really leading our monitoring effort from out on the Malheur National Forest, the leadership of the Blue Mountains Forest Partners. So without any further ado, I'll get started. First, we need to locate ourselves here on the Malheur National Forest, the area that I'm going to be talking about. I had thought to include a map of Oregon so as to place Malheur in the context of the Great Pacific Northwest. But for those of you who don't know, John Day is in the central eastern part of Oregon, and the 1.7 million acre Malheur National Forest is in the southern Blue Mountains, just about 6 hours due east of me here in Corvallis. The green shaded area is the Collaborative Forest Landscape Restoration Program area. This is an area that's been designated as one of 23 high priority landscapes within the National Forest System to receive augmented funding from Congress to accelerate the pace and scale of restoration on this forest. Congress has dedicated a total of $17 million in additional funding to the Malheur National Forest for accelerated restoration within this CFLRP area. And to date, we've accomplished approximately 250,000 acres of upland forest restoration treatments. The CFLRP program also pays for the monitoring work that I'm going to describe to you now. But first, here's a conceptual model for how monitoring and adaptive management work out on the Southern Blues CFLRP on the Malheur National Forest. Key partnerships, one key partnership is between the Blue Mountains Forest Partners and the Forest Service. The Blue Mountains Forest Partners has a strategic plan that's revised at least once every 10 years, and usually more often than that. The strategic plan calls for monitoring and research, which informs periodic adaptive management assessments, which in turn inform our zones of agreement documents, which are consensus statements among the Blue Mountains Forest Partners membership, which includes local elected officials, folks from the timber industry, folks from the conservation movement. Theoretically, at least, these zones of agreement could inform the forest plan for the Malheur National Forest and site-specific projects. And of course, those site-specific projects is where we collect data that informs ongoing monitoring and research. I believe that this adaptive management framework has been highly successful. We're on version 2 of our upland forest restoration zones of agreement, last revised in 2017. We're deep into the process of creating version 3.0, which is heavily informed by the results of ongoing, ongoing adaptive management. Less successful at informing the Malheur National Forest Plan, which is more than 20 years old at this point and is going to be revised sometime between the next 5 years, between the next 5 and 100 years. The multi-party monitoring involving the Blue Mountains Forest Partners, the Harney County Restoration Collaborative, Oregon State University, and the Malheur National Forest is of two types. The first is observational. Dave Hannibal has for many years been leading our monthly field trips to observe firsthand what restoration projects look like out on the ground. We review data, we look at stuff, we talk about it. The other type of monitoring we do is data-driven. data that we collect in the field on an annual basis and analyze back here at the lab at Oregon State University. There's lots of ways to divide up forest vegetation on the Malheur National Forest. One way to do it is to speak to dry pine forests, those forests that were historically and are today dominated by our friend, the ponderosa pine. And there are mixed conifer stands which have ponderosa pine and a mix of other species, including grand fir, Douglas fir, western larch. Some lessons learned from our observational monitoring in dry pine stands. In general, we think that basal area targets of approximately 30 to 60 square feet per acre are appropriate for achieving the objectives set forth in our zones of agreements. We don't want for that residual tree cover left over from mechanical thinning to be uniform. We're always looking to create small patches and openings. An important observation and recommendation that's come from the Blue Mountain Forest Partners out of our qualitative observational monitoring is that we should be meeting these basal area targets at a unit scale. That is at the scale of tens or hundreds of acres and not on an acre scale. When you achieve 30 to 60 square feet of basal area post thinning on a per acre scale, you get things that are pretty uniform, and we're looking for more heterogeneous spatial conditions following thinning. Something more like this, where there's both gaps and openings and a little bit denser forests. One lesson from our observational monitoring is that we're not doing enough to remove moderately and strongly shade tolerant species like Douglas fir. Here's an example of a treatment unit that we think that we could have removed more Douglas fir. We're also interested in removing trees from areas that were historically treeless. Here's an example of a meadow edge where trees have encroached into that meadow. And both in the interests of long-term resiliency and sustainability of these landscapes and management of future insect and fire disturbance, we think it's appropriate to break up those contagious disturbance processes by creating openings and restoring that historical configuration of large openings and forested areas. Here's another example of a former meadow that's totally infilled with ponderosa pine. In mixed conifer, basal area targets of approximately 40 to 70 square feet per acre are appropriate. Again, we want to meet those basal areas at a unit scale, not an acre scale. And again, we want to remove more shade tolerant species. Here's an example of a thinning project, the Elk 16 thinning project on the Malheur National Forest within that Southern Blues CFLRP, where we think it would have been appropriate to remove more of that shade tolerant and drought and fire intolerant grand fir structure. We have consensus to aggressively restore aspen stands. Aspen is a species that's critical for habitat diversity and biodiversity in the Southern Blue Mountains. It's a light-loving species that needs to be free of conifer competition to thrive. And we do support pretty aggressive conifer removal in order to stimulate aspen regeneration, as you see here. Very significant conifer removal at this site. We're actively going to be monitoring this to see if we can't get all the bare earth you see literally covered in aspen. In all forest types, we acknowledge the need for more fire, both prescribed fire and managed natural ignitions, in order to achieve surface fuel reduction goals. So now I want to talk about our quantitative data collection efforts out on the Malheur National Forest. This multi-party effort is led by Harney County Restoration Collaborative, the Blue Mountains Forest Partners, the Malheur National Forests, and Oregon State University. And this is very rigorous data collection in the field. We currently are working in a plot network of approximately 550 plots spread out across randomly selected planting areas and randomly selected treatment units within that CFLRP. In these plots, we collect data about overstory tree structure. We collect data about surface fuel loading, woody particles, litter, duff, live surface vegetation, and we quantify understory vegetation diversity. One of the lessons from our quantitative monitoring is that fine fuels matter a lot when we're talking about fire behavior. Here's an example of a stand before fire and after fire. I hope you can tell that that's the exact same stand. What's being burned away, what the fire is consuming, is not the merchantable tree material that's removed to a timber mill in the course of restoration thinning. What's being consumed by fire is the fine surface fuels, particularly the fine surface fuels on the forest floor. So we're very interested in quantifying changes in that surface fuel over time in thinning operations. It's entirely possible that thinning actually increases surface fuel and has the potential to exacerbate fire behavior, because when you fell trees, you put a bunch of that fine woody material on the forest floor. We investigated these questions. Well, the first place that we were able to build a long data set is in the Marshall Divine planning area on the south end of the Malheur, where we gathered data in every year between 2014 and 2019. Thinning was completed at the end of 2014, and you can see, again, this is a time series photograph. You're looking at the exact same scene, both before thinning in 2014 and 5 years after thinning was completed in 2019. So relatively aggressive mechanical removal of conifer cover. Here's some of the results of our data collection of modeled fire behavior informed by the data we collected about surface fuels. We input our surface fuel data into the FCCS fire behavior modeling environment, and we modeled 3 metrics that are extremely explanatory of fire behavior and predictive of severity. We modeled rate of spread in meters per minute, flame length in meters, and reaction intensity, which is simply the heat energy that the model predicts is being released by fire. So those are the variables you see on the y-axis of these graphs, and on the x-axis, you see the years 2014 through 2019, remembering that the 2014 observation is before thinning was completed, and the 2015 observation is immediately following thinning, and then in every year since. And what you see is an increase, sometimes a slight increase, sometimes a moderate increase in all of these modeled fire behavior parameters immediately following thinning. But within 2 or 3 years after thinning was completed, we see a dramatic decline in modeled fire behavior. This graph shows a little bit more detail about surface fuel loading over time. I want to particularly call your attention to the 2 center graphs on the right-hand side there, where we show litter fuel loading and duff fuel loading over time. The first thing you should notice is on the x-axis, these are by far the largest surface fuel components by volume. That is what fire is consuming in fire events for the most part, is litter and duff. And there are pretty significant declines in litter and duff following thinning, which is a little bit surprising because, of course, we're not hauling the duff and litter away to the timber mill. It remains on site. But what we find is that the process of mechanical thinning, which disturbs the soil, and the result of mechanical thinning, which is opening up the canopy, significantly mixes the duff and litter layers with dirt. And it also decreases duff and litter because there's less deposition of litter from overstory trees. Less trees equals less litter, and more solar radiation is associated with more decomposition. This is another repeat time series, and you can see where the arrow is pointing that duff and litter layers have gone from 3 or 4 inches deep to, in many cases, less than a half an inch deep over the 4 or 5 years since thinning was completed. We think this is the primary mechanism by which we're observing, significant moderation of mottled fire behavior. Another thing we're really interested in is biodiversity. How does species diversity respond to thinning over time? Another thing we're interested in is resilience and resistance of overstory trees that are left after thinning. We are estimating radial growth by coring trees in some of these thinning units. And here's some quick and dirty results to share with you. These box plots show, first of all, Shannon's diversity index, which is an index of species richness in 2014 before thinning was completed, and 2018, 4 years after thinning was completed. The box plots show the range of values. The black line in the middle of those box plots is the median value. And we can see that there is significantly more species diversity in the understory following thinning. The primary reason for this, of course, is that by removing overstory tree cover, we increase light to the understory such that light-loving forbs, flowers, and grasses have more light resources in order to grow and thrive. I feel like there's 100 other things that I could share, but I'm going to end it there, giving you just a taste of what our monitoring program looks like. Oh, I forgot all about radial growth. Well, this is pretty straightforward. This graph just shows basal area increment in square millimeters. In 2014, before thinning, the thin stands and the unthin controls had approximately the same basal area increment. Basal area increment was, again, approximately the same immediately following thinning and the year after thinning. But in just 2 years after thinning, we see a lot more rigorous radial growth in those trees that remain after thinning, which is highly predictive of trees being able to survive fire and insect attack. So with that, I really am done and want to turn things over to my colleagues, Mark, Susan Jane, Pam, and Dave, and perhaps just open things up to discussion. Before that, I want to first acknowledge my co-principal investigator, Becky Miller, the BMFP. Becky's the brains of this operation, and I was really thrilled to see that. I think that she's on the Zoom call today. And hopefully Becky can be available to answer some questions. BMFP staff and board, Malheur National Forest, and of course our dedicated field technicians who do all the real work that makes this data analysis possible. So what do you say, Trent? Should I stop sharing and turn it over to Mark, SJ, Dave, etc., or open things up for discussion, or what's your pleasure?
Yeah.
Thanks everybody very much for having me. It's always just fantastic to be able to appear at a Sustainable Northwest event and to share this stuff with you. Eager to have some conversation.
Great. Thank you, James. Yeah, I would suggest if you stop sharing your screen, we can have the panelists open their, turn on their cameras and unmute themselves. And then we can hear from each of the panelists about your experience and engagement with monitoring and adaptive management. And then it may be at the end, James, that we will want to review. People might have questions about their slides. So what order would you guys like to go in?
I'm happy to jump in first and get us started. If that is all right with my fellow friends there at BMFP. So just another run of introductions. My name is Susan Jane Brown. I'm a staff attorney with the Western Environmental Law Center in Portland, but I'm also a founding member of the Blue Mountains Forest Partners, and I'm on the board of directors, so still engaged. And I just wanted to offer a quick reflection about some of the stuff that James was presenting for our fellow collaborative members. And that is really that I really can't speak highly enough of the value that our science advisors, which include James and Trent and some others, have been able to provide for our collaborative. Having that sort of science engagement and science delivery has been really helpful for us as a collaborative to come together and have a shared vocabulary and shared understanding of what is going on out in the forest. And by engaging with science and having science inform our decisions, I think that the decisions that we make are just frankly better informed. We have an understanding of what we expect to happen, and we monitor to make sure that that's actually what we get. And sometimes it is, and sometimes it's not. But that's also a crucial part of the adaptive management cycle. And going out, experimenting on the ground, doing some restoration work, monitoring it, and seeing whether or not we're achieving the objectives that we were hoping to achieve is an essential part of making sure that we make the right land management decisions on the ground. So having this kind of information that can give us pretty regular and contemporary feedback to how we're manipulating the environment and whether we're getting what we want out of it has been really essential for us. And so for those collaboratives that are just starting out or trying to figure out how best to infuse science in your decision making, I really can't recommend it highly enough. It does take a little bit of work, and I'm a lawyer, so you don't want me designing your monitoring protocol. But having someone like James who has that expertise is really important, really helpful to getting everybody on the same page, and then hopefully being able to make decisions based on that information. And again, we don't always get it right. We are human, so we are fallible. We do make mistakes. But the idea is by having a monitoring program in place that can basically give us the triggers that we need to change our actions, change our management in response to the results of our treatments is really essential to being pretty confident that we're making the best decisions that we possibly can for the landscape and for the communities that are dependent on it. So I'll stop there and turn it over maybe to Dave Hannibal, if you want to talk a little bit about your perspective on this.
I don't have a whole lot to add other than to double down on what you just had to say. Trent and James have been just instrumental in helping us get to where we are, especially in the early stages of collaboration, where your membership is so far apart in views, and to have that scientific background. And I think we've helped them maybe alter their perceptions a little bit of pure science versus the forest. Sometimes there's a meeting there that works and sometimes it doesn't. Don't have a whole lot to add there. Pam, you got anything to add?
Sure, yeah, I'll jump in. Thanks, SJ, for just nailing it. Yes. I think that the big thing that I would add is it's just a little bit of a personal story. It's really, when I first came to Blue Mountain Forest Partners and was trying to figure out what was up and what was down, it was really, I probably came as much as anyone, or more so than anyone on this panel, with the perception that there wasn't probably anything you could do that was of any use in the woods with a chainsaw. And it was really the rigor of the science that got me to open my eyes and really think about, wow, maybe there's really another way, and to really, step by step, really change my perspective on that. And it's not just the rigor of the science, because James and Trent spent hours in the woods with us, hours in the woods, going back to certain places and talking about what's up. And what was always really significant and impressive to me is you go out and I'd raise my hand and ask some silly question, and I'd get an answer that was not just like an answer, but that provided more nuance and depth and detail than I even knew was available to answer that question. And that level of engagement with the scientists who are actually out there doing the work as a part of this monitoring project has been, at least for me, an absolutely essential part of really building that social construct in which we can all look at each other and go, yeah, this is reality. This is what's actually going on out there, and numbers don't lie. We got the numbers, and we really share an understanding of what's happening. So those are the only little aspects that I would add. It's the time on the ground, and it's the rigorous recording of what is found and what is understood, and getting it back in to our adaptive management process. Coming up with round 2 and round 3 of the zones of agreement that actually specifically include the information that we found. And James has been super helpful in terms of, taking us out there. And, just to mention one of our key understandings, that basal area should be measured on a unit scale and not just on an acre by acre scale. That was an agreement that we really had to get out in the field and talk to, and one that, over the course of several field trips could easily be sort of forgotten, and just we could continue to go our merry way, just saying one thing, and then what gets written in the NEPA and the prescriptions being something else. The rigor of getting it back into the adaptive management process has been really helpful, and something that I recommend people and collaboratives, across Oregon and across the West really think about how to make sure that actually happens and that actually gets changed. I think those are my only things I would emphasize. Thanks so much.
Yeah, so I might just rephrase what's already been said, which I agree with. I do think it's important for people to appreciate the context in which BMFP started, which was an incredible amount of disagreement and no shared sort of common space. And it was a commitment to following the science, not that we believe science tells us what to do in every case, but it was a commitment to learning about what the landscape needs, since we had committed to restoring the landscape. And it's the monitoring component, both the observational, qualitative aspect and the data-driven part of that have really informed both our ability to come to agreement about what that landscape should look like, and enabled each of us with our respective values, whether it's environmentalist or conservationist or timber industry or service industry or community member, to begin to see how to envision what their vision looks like for what this landscape is and needs to be. And so that's been really critical. And I think I'd also stress that for any kind of force that's serious about managing the public landscape, I think it's almost impossible to do it short of a rigorous monitoring program that can inform adaptive management. There's just no way around it for a variety of reasons, both for the science to inform the conversations as well as facilitating social agreement. And having said that, I saw several national, or not national forest, but former National Forest staff on this. And I'd really like to ask, say, Nathan or Amanda, who have been a key part of our field trips in the monitoring program, if they're able to share in what ways this has enhanced or maybe complicated their responsibilities with the Forest Service, because it's been our desire to enable the Forest Service to do good work, and we feel like this has happened. So I'd like to hear from them. I'm pretty sure I saw their name on there, did I not?
I think they're there, some of them.
We have Joe Roush. Maybe Joe, would you want to join? I don't see Amanda.
I'm here.
Oh, good.
Joe on? Okay.
I don't, once I heard you weren't calling my name, I didn't listen to the rest of your question, Mark.
So the question for the Forest Service is, in what ways has our monitoring program, which y'all are key component of enhanced your efforts, project planning, treatment prescriptions, or complicated it? I mean, we feel like it's absolutely critical for our success that this monitoring occur. What's been your experience? I think people need to hear that from the Forest Service.
Yeah, it's, I mean, in a way, it affords us kind of the social license through the Mountain Forest Partners and the Harney County Collaborative. So that's a big one. Even if we don't have the results right away, because it takes a while to collect data, takes a while to analyze the data, and we're starting to get returns on those investments, if you will. But in the meantime, it affords us that social license to try new things, to keep using old things, maybe shift some of our prescriptions as we all go out there and we see that maybe this particular unit doesn't look like what we had envisioned it before before it was implemented. So there's that, and I know our silviculturists definitely use some of the preliminary results and some of the already published results that either directly part of the monitoring program or are kind of a tangent of it. So yeah, I'll stop there. And I always love seeing the results as they come in. It's like a Christmas present. I mean, even if I'm not interested one way or the other, it's I love data and like to see what the data is telling us about our land management.
Thanks for being put on the spot.
Yeah.
I might just add one more thing, and then Trent, it's yours. I do, Joe brought it up. When we began, I think I like to repeat this, the one thing that the environmental community and industry agreed on was their dislike and distrust of the Forest Service. And so I say that with a laugh because we're all key partners right now. But I think what's important to appreciate is twofold. One is that the qualitative observational component of our field trips and monitoring approach, we've had to see visually, where we've gotten things wrong before. We've had expectations, we've gone out and it's not what we thought, even though the Forest Service essentially did what we asked. And so that's been important in terms of our partnership relationships, self-awareness, and a certain element of humility. So I think that's one key component of the observational part. And then just speaking for myself here, I would hesitate to develop a monitoring program that was just built on the qualitative observational component, because it's really critical that we have the data, the rigorous, the science-informed kind of monitoring information to help us change how we look at the landscape. So those need to work in tandem. I think BMFP is committed to that, but I did want to share that as my own view, that one or the other by themselves is going to be much less effective than traveling together.
Yeah, dovetailing on that a little bit, Mark. Our early agreements were basically weak silviculturally, and they didn't meet what we wanted, but it was what we could agree on. And so you're going to have those at different stages of different collaboratives, where what you might be able to agree on is not going to be the greatest thing on the landscape. But as you go back and continue to monitor, we're just going to keep refining that. Now, as an operator, one of the complaints that I hear a lot is we keep changing the rules. And operators like to get a concept down and then stay with that and run with it. And as we keep altering things, which we actually don't that much, I'd like to see us still continue to alter our prescriptions a little bit more than what we have to date. But it just becomes a concern. You don't want to be changing the game all the time on the people out there that are implementing that. But we continually need to look back and be refining and saying, are we doing the right thing? Is this exactly what we want? We still don't even come close to meeting species composition that is our desired target out there, because it'd be hitting the forest way too hard. I'd still like to try that somewhere, but that's kind of where we're stuck with. So that's all I got.
Okay, well, we'll continue the panel, but people can send questions through the chat box. And then I'll share those questions with the panel, and you guys can decide who'd like to answer them. So we've had a series of questions come in. One of them is, can you share what the CFLRP monitoring budget has been both annually and for the 10 years?
It's been approximately 10% of the total annual appropriation of, I believe it's $3 million a year. Someone correct me if I'm wrong.
Yeah, it's, so we have, our CFLRP boundary was expanded. So the monitoring budget's been 10% roughly of anywhere from $2.5 to almost $4 million annually. So $250,000 to $400,000 annually.
I'll say so initially we had a total budget of our CFLRP around $2 million or 2.5 million. And so we designated 10% of that to monitoring. But then about midway through, we had an expansion and more money came in, about 4 million per year. And we really didn't adjust upwards. So it kind of stayed right around that $250,000 a year level. So whatever the math is on that. But I'll say the last few years, as we have more information in some of the other areas, it seems like the monitoring budget is decreasing as we're just working to keep some of the programs going, like the one that James is working on. And some of the other ones, we feel like we have enough information, some of our watershed and invasive species. So we're not really dedicating much funding to that.
There's a bunch of different monitoring programs. The work that I described, monitoring upland forest restoration, has been ongoing since 2014. Between 2015 and 2021, that monitoring budget has ranged between $114,000 to $139,000 a year over that 5 years or whatever.
Great, thank you for that. That helps answer some other questions that came up, which was how much would it cost to replicate? So just to clarify for those who are interested, James presented on a specific component of monitoring, which was fire, fuels, and vegetation, but there were multiple other monitoring projects happening that aren't being shared today. So another question we have is any of this funding for monitoring available to adjacent landowners, or is it just for the Forest Service?
That's a great question. As far as I know, the monitoring budgets are only available for work on Forest Service lands. I have only been involved in monitoring on Forest Service lands. That's the only answer to the question I have, but other people can weigh in.
Yeah, I think, and it has to be within the boundary that was that first map that you showed. So if there happens to be private lands that were within that and we have an agreement with them, then in theory, it could happen. We might have done some of that with our invasive species monitoring.
Yeah, and I think if the question is the data actually available to others, the answer is yes. Much of James's work has actually gone through the publication process, so it's been peer reviewed and is published. And I'd be willing to bet that James would be willing to share his raw data with anyone who is interested in it. even if it's not a, even if it's not the Forest Service, if it's state or private or tribal land, because the implications are important for all of us here in the Blues.
Okay, people can keep sending questions, and if you have them, I'll keep going through these. So what about monitoring wildlife? Is that a separate project that's happening, and how much does it cost to monitor wildlife?
We have a couple monitoring programs that are related to wildlife. One of the most important is monitoring and research carried out by Dr. Vicky Saab's group at the Rocky Mountain Research Station. They have two projects that have been ongoing for a while and are in fact kind of wrapping up. The first quantifies the effects of restoration thinning operations on white-headed woodpeckers. And the second quantifies the effects of fire and salvage logging operations on 3 different woodpecker species in the 2015 Canyon Creek perimeter. And these have generated really useful information to inform future upland forest restoration and salvage logging prescriptions. Trent has been trying to get some marten, and there has been some marten monitoring work done that I'm not myself super familiar with. That's what I know. I think there are probably other efforts underway that I am not as familiar with. So someone else feel free to add to this.
Yeah, I think
Was
you're
there
right. Chief.
anything,
The
John?
monitoring money was part of the white-headed woodpecker research, which is part of a region-wide effort, actually not just on the Malheur. So it includes the Okanagan, Wenatchee, and I think the Colville, and then the Fremont, Wainema. And so that's both field data to create habitat suitability models. And that's the wildlife data that's used with the CFLRP money. The Malheur has separate wildlife work happening, which includes marten modeling and other work, which was not part of the CFLRP, which was separate funding. Go ahead, Mark. Did you have something to add to that?
No, I was just going to ask Joe. That was our recollection. It mostly focused on the woodpeckers.
Yeah, that's right. And in fact, that's most of all the monitoring we've done is not accomplished by National Forest System personnel. So either universities, and we've had a couple other, we had a spatial pattern monitoring that was done in collaboration with the University of Washington, and that resulted in a publication. There was another one that looked at landscape patterns that actually became an online tool through a Forest Service group in Fort Collins. I forget what their acronym is. And then, and the white-headed woodpecker monitoring by the Rocky Mountain Research Station. But pretty much the only monitoring that was done by National Forest System people was the invasive plant monitoring, which actually was a kind of a double whammy because we were funding, so it almost could be considered not monitoring, but we were funding invasive plant treatments within the project boundary, and we're also required by Forest Service policy and in some cases law to monitor the effectiveness of our treatments, and that co-occurs while we are monitoring. So pretty much everything was done through partners, either government partners or university partners, and in some cases here and there some small service contracts for some of our aspen photo point monitoring. And all the monitoring designs were kind of set into motion at the very beginning when we had some meetings with the collaboratives and kind of settled on a few core questions, thinking that it's better to do a few things really well than a bunch of things mediocre.
Okay, we have more questions coming in. This might be one for you, James. Can you share an example of how you scale up monitoring metrics from the project scale to the landscape scale? And do you evaluate and analyze those metrics like basal area differently when you cross those scales?
That's a great question. I think, and I'm not sure if I'm going to answer the question that's actually being asked. So whoever asked the question might want to clarify. But it's a really important and critical question whether we can make inferences to landscapes using measurements at a plot scale in two respects. First of all, simply whether the stuff scales up or whether there's emergent properties of these measured attributes at landscape scales in terms of large scale contagious disturbance like fire or insect or drought. One of the things that we are doing more of is using the field data to validate models derived from remote sense data. So we are currently estimating changes in forest cover, changes in basal area, changes in forest density, using remote sensed satellite data trained with our plot-based data. And we look forward to making some pretty robust inferences about change over time using that information. But I think that much more needs to be done in terms of, first of all, using and creating reliable landscape scale models. I think at this point I'm kind of rambling, so maybe whoever the question came from could clarify or amplify and see if I can't give you a better answer.
Yeah, hi. I asked that question. I was just trying to get at thinking across scales is really challenging to do, especially thinking about the monitoring metrics and the goals that you're setting at the project scale and landscape scale. So I'm just curious if you've been able to take some metrics like basal area or canopy cover, species composition, and kind of evaluate it differently at the project scale and the landscape scale. I'm guessing that's going to be highly dependent on what goals you're setting at the project scale versus the landscape scale. But it's something that I think a lot about and just want to hear from some other folks how they think through that process. But your first answer was great because I'm always looking for other ways to use project scale data in other ways than just evaluating landscape scale goals.
Yeah. The first and most important point to make here is that we are actually doing landscape scale restoration on the Southern Blues CFLRP on the Malheur National Forest, which frankly, and this may be a controversial view, but I don't think that any other national forest really is doing stuff at a landscape scale. We treated 250,000 acres in 8 years, and we're planning on treating another 250,000 to 500,000 acres in the next 10 years. And it's a really good question whether our stand scale observations scale up to the landscape scale when we're talking about drought resilience or resilience to fire or insect attacks. And the short and best answer is I don't know. The long and more detailed answer is that we are currently test driving some different ways to do that. The primary mechanism is to try and see if we can't get field-based observations to talk to remote sense data in a way that we can make inferences across the landscape scale with the remote sensed data. But the larger challenge, and we're nowhere close to being able to do this, is to develop rigorous modeling environments that are good representations of actual reality that run at landscape scales. Some folks may be familiar with Landis 2 or other modeling environments, which may do a decent job of representing, for instance, fluxes and carbon stocks, which is of great interest to folks. But we probably don't have any good way to speak to more amorphous concepts of resilience or resistance to disturbance at those scales. And that remains a important need.
Great. We're getting plenty of really good questions here. So can you share what the monitoring budget actually pays for? I think that's more of a detailed question of how the budget's broken down.
I should, first of all, feel free to email me and I will give you a very, very precise estimate, or rather a really precise answer. But my best estimate off the top of my head is that approximately 3% is supplies and equipment. Approximately 12 to 15% is travel and or housing. Approximately 2% is publication costs. 1 to 2% is computing. Around 10 to 12% is indirect costs. And the remainder is personnel, salaries, and so forth. If you're interested, though, email me and I'll give you a more precise breakdown on a annual or total basis.
So James, there were a few questions about the basal area, the basal increments that you showed increasing post-harvest. And so can you talk about what that means for individual trees increasing their basal area increment versus the stand basal area? And what would you expect to be happening at the stand basal area when you see those big increases at individual tree level?
I probably should have done a better job explaining that graph. The first and most important thing to note is that in that particular monitoring area and throughout the areas that we monitor, there are pretty significant reductions in basal area, stand basal area associated with thinning. Typically somewhere between 1/3 and 2/3 of live tree basal area is removed in the course of thinning operations. So what we're looking at in that case is basal area increment, not basal area, but radial growth, how much area trees are adding to their circumference on an annual basis in those trees that remain following thinning. And we do that comparison both in terms of time since thinning and also comparing trees in thin stands to trees in unthinned stands after accounting for diameter, height, and some other variables that also influence basal area. And we find that there's pretty significant increases in radial growth of trees following thinning, which means that trees are better able to utilize sun and water resources, primarily water resources. And that increased tree rigor is strongly associated with resistance, based on previous research, is strongly associated with better ability to resist attack from insects and damage from fire. There's a number of other analysis we've done with tree physiological responses, including resin flow, isotopic fractionation, which is a measure of drought stress, abundance of non-structural carbohydrates in tree tissue, bunch of pretty fancy analysis, all of which point to these trees being much more resistant to insects and fire after thinning, which is not surprising. It is the point of what we're doing. But I think that it's somewhat surprising at how fast those responses occur. It's typically 2 or 3 years after thinning that we notice a statistically significant response. So I'm
Great.
rambling again.
Thank
Yeah,
you.
cut me off, Trent.
This one might be for Joe, or maybe someone who's familiar with the overall. We had a couple questions about the aquatics monitoring, and if someone could speak to whether you are doing aquatics or watershed monitoring and hydrology, and what is that monitoring that's happening?
I can speak to that. We have, there's two major monitoring efforts around aquatics. One of them is we added some extra sites for the PIBO team. That's the Packfish in Fish Biological Opinion team. They basically look at long-term condition and trend of streams throughout mainly the Intermountain West. And so we're using some of their data, but we added some extra sites. And then we also have a monitoring designed just to look at some of our aquatic restoration projects. And most of that was not really funded through our CFLRP dollars, but our area ecology program in the Forest Service. In this case, they're out of Baker City. They were collecting, along with some of our seasonals on the Malheur National Forest, collected data, both pre-data and post-data on some of our major aquatic restoration projects where we're putting in, or where either we're realigning the channel or we're putting in beaver dam analogs, things like that. And so we collected a lot of vegetation data before and after, and we're currently, doing that at the first year after, and then like the third or fifth year after, just to see what the changes are in vegetation. So are we getting the anticipated effects of having, expanding the wetlands, creating more wetland habitat, and we're really just looking at the vegetative data, so we're not putting in like any wells or really looking at the soil. But kind of the thought behind that is, one, it takes less time and is much less expensive just looking at the veg data, but also if we're seeing an increase in obligate wetland species and increase in willows and other shrubs, and sometimes we're planting those, but so in that case we're looking at the success of the planting. So results yet to be determined on those, but sometime in the next couple of years we should have some results.
Great, thank you, Joe. And this one, I think it's just a clarification. The work that you're monitoring is part of the 10-year stewardship contract on the Malheur, but the actual monitoring and adaptive management is not in the stewardship contract. It's separate from that. Is that correct?
Yeah, I would say it's not just the 10-year stewardship contract. We're not just monitoring that, but yeah, the monitoring has no relation necessarily to the 10-year stewardship contract, other than we're looking at, or we're monitoring some of the work that has occurred as a result of that. But we also have other open timber sales and other, other activities that are happening out there, prescribed burns, that type of thing, that are also being monitored.
Okay, this one I think goes back to the rest of the panel. You've spoken to the importance of developing the zones of agreement and also having field trips and data-driven approaches for informing the purpose and need of the restoration. Can you speak to other activities or other documents and entities or groups that you work with that you would consider key ingredients for this success of your work in the adaptive management in the Southern Blues?
I'll jump in on that. One of the processes that I'm involved in some other collaboratives right now, and it hasn't been just on the Southern Blues, has really been around shared learning. And, I was not a part of, excuse me, setting up the shared learning processes on the Southern Blues, but I joined really in 2014, and then started doing that on some other organizations. And I would say that one of the key things to moving forward with this is, if you're going to go through the process of really trying to bring a collaborative up to speed on what the current science is, what the problems are, it's really important to have somebody who can sit down and identify the questions that are really at issue and develop yourself a set of understandings about what you think a zones of agreement ought to look like at the beginning, and then a curriculum for yourself about how to move through that information. And then as you go through various different presentations by scientists or go out in the field with somebody or something like that, it's really critical that that information is actually captured in some kind of, it can be just a set of bullet points, but it needs to go into the collective record so that as you come to the end of your curriculum process and shared learning process, that you can look back on that and say, okay, we learned A, we learned W, we learned J, and put those all together and have them make sense. One of the things that can happen in a shared learning process if you don't do this ongoing documentation is that you have this great presentation and 20 people went away feeling really enriched. And then 6 months later, you have 15 different remembrances of what that presentation actually said. And some of them overlap and some of them don't, and so on and so forth. And so that documentation along the process of the shared learning process is one of the other key pieces of documentation that I would say is really necessary for making collaboration work around this kind of work. And it's sort of a form of monitoring your own collaborative understanding.
Great. Thank you, Pam. Go ahead, Mark. Did you want to add to that?
Yeah, I heard a slightly different aspect to the question as well. What I would want to say is that we feel like most of the key stakeholders are currently participating in BMFP and HCRC. But I think it is important to acknowledge that there are some groups have walked away. And with respect to those groups, for example, around riparian restoration or maybe project-specific 21-inch rule amendments, we've attempted to invite them back and have field trips, provide opportunity for them to provide their science, discuss that. So we've attempted, even though they have reasons for stepping away, to nevertheless engage them in those ways. We've attempted to be pretty open and inclusive, even if it's not within our normal structure. So I just don't be surprised if groups step away. Also continue to try to reach out. Both Pam and SJ have been really critical about that. I think that's pretty key to collaboration being an effort, a process that exhibits integrity.
So there's a question if the Forest Service or the collaboratives with the CFLRP monitoring have any plans for measuring carbon sequestration.
Yes.
As the non-scientist, I'm going to say there's not enough to measure here.
I think carbon sequestration is an increasingly important thing to get our heads around. We don't have the answers yet. There's some great science coming out around west side forests and around certain tree species. Been some really, interesting enough pieces of science come out about it that I think it is time for us to really get our act together. I think another key question that we really have to address with climate change in particular is just how is it going to address these forests, and how do we balance carbon sequestration and fire risk? It's a really simplistic answer is just to say, well, the more trees you can stuff onto any given acre, the better off you're going to be. But we have the peculiar situation in Eastern Oregon that I'm sure all of you are familiar with, that if you stuff too many trees on any given acre, you end up with stand replacing fires, which negates the whole point. So I in particular have to say, I am very much looking forward to understanding how to balance those things.
Great. Adding on to that, and I think you were just touching on this, Pam, but what are you thinking with adaptive management around climate resilient forestry? I think that's more to do with planning for future disturbances and not just a historical range of variability or current drought and fire.
That is a scientific question. And yes, we're planning for it. I'll stop there and let somebody who's better at describing such things actually pick up.
Well, since we just wrote this in our CFLRP re-application, I know what we wrote. So what I could say on that is that we're absolutely planning for climate change in a couple of important ways. One is really focusing on reducing basal area and shifting species composition to more drought and fire resilient species, and doing that in a way that there are frankly just fewer trees out there, because we are going to have less water availability in the future. So we need to account for that in the number of stems per acre we have. The other thing that we're doing is, and I know that a lot of collaborative groups are focused on this, is getting more prescribed and managed fire on the ground. There is no future forest in the blues without more smoke and fire. And so we need to figure out a way to make that manageable for the human communities that are out here, as well as the wildlife and the forest itself. And so reducing basal area through mechanical treatments, but then reintroducing fire so that fire can resume its more natural role in the ecosystem are two pretty key aspects of our restoration treatments that we have been doing all along. But not only has our monitoring told us that we're definitely on the right track, but also the climate projections for this region are further pointing us towards continuing to reduce basal area so that our forests can function in a climate constrained way. And so I will stop playing scientist and let James correct what I messed up.
No, I have nothing to add.
So this one, you've addressed this partially, James, but this is a more detailed question about scaling. And that is, and you said that you're monitoring at the landscape scale for landscape scale effects. Can you talk about the difference between that being a product of collecting data at the landscape scale, which informs the model, or the data itself answers it without the need for a model on the effects for fuel and fire and drought?
If I understand the question, the answer to both questions is yes. First, we are able to make inference to the entire landscape with our plot-based data collection, because those plots are, well, they're random selections from the population of interest that are really widely distributed, and so I think are allowing for robust inferences to the landscape. We could probably tell you just on the basis of our plot network how basal area is changing, how species composition is shifting, how understory vegetation is responding to thinning, how surface fuel loading is changing. Could probably tell you a lot about carbon stock fluxes. But we can also do that, by linking that field data to remote sense data. And in some ways, that's probably a better and more comprehensive view. What is still lacking, though, is being able to mechanistically link these changes in measured quantities to a landscape scale response to climate, fire, drought, et cetera, et cetera. It is the case that we do have a pretty good idea of how stands and individual trees are responding to thinning and how they are going to adapt to changing climate and disturbance regimes. But there are emergent properties of these disturbance regimes that are operational at landscape scales, and I don't think that we well understand how thinning scales up in that sense. Did I answer the question?
Yeah, there were multiple questions leading around that, James, and you'd answered some before. I think that was great. So here's a question, compiling multiple questions again. You're talking about zones of agreement and decision-making. Can you guys explain the difference between how that represents your adaptive management versus the suggestions you have to the Forest Service for them to use adaptive management? And I think the piece here, if I could just interpret this, is that I think you guys missed out on that. You started out with much more primitive zones of agreement and they evolved over time rather than you arrived at this amazing space full of data and science and agreement. So you might want to share your evolution of zones of agreement and your own internal adaptive management, and then maybe speak to how that leads to your suggestions that the Forest Service adapt their management.
I just want to say quickly that this is a question for an attorney.
And now I'm confused about what the question actually is. Are we talking about our adaptive management? Are we talking about the Forest Service's adaptive management?
Both. So feel free to address one at a time. Yeah.
Okay. So which, I couldn't hear you, sorry.
Oh yeah, so both of those. If you want to speak to your internal adaptive management and how that affected both you socially as a group of diverse stakeholders, and then how that shifted your suggestions to the Forest Service, and then
Sure.
maybe separately, if you're expecting the Forest Service to continue to adapt, or if those are represented in your zones of agreement.
Sure. Yeah. So I think, Mark touched on this in terms of our own internal learning as a collaborative. We started out with a lot of, I think, preconceived notions about what was happening on the landscape, and we were all bringing our individual perspectives to the table, whether you were, an industry person or a contractor or with the environmental community. And so what our focus on allowing science to guide our decisions has had, the effect has been that we kind of all have to check our assumptions at the door, and we're going to let the science guide the direction that we head. And so as we have talked to experts on any issue, whether it's aspen or wildlife or aquatics or terrestrial upland forest vegetation, we've basically just had to adjust our expectations and our understandings, because we're talking to people who actually study this stuff for a living and aren't lay people. They are experts, which isn't to say that we can't and haven't brought our social expectations to the table, but those expectations and those desires are different than raw science and data and an understanding of forest succession and process and disturbance and all that kind of good stuff. And so as the collaborative has spent time in the field talking to these folks and reading the associated literature, over time, we've certainly adapted our perspective on these things. Me personally, when I first became involved with the Blue Mountains Forest Partners, which was back in 2003, I couldn't see much of a reason to remove a large diameter grand fir from the landscape because it was a big tree and I liked big trees. The fact of the matter is that over the past 20 years, we've learned that those big grand fir are in fact compromising the ecological integrity of the old growth ponderosa pine and larch that historically were present and should still be there on the landscape, but are nowhere near the density that they were historically or we would want in the future. And so the science has really caused, I think, each individual of the member of the collaborative to change our expectations. And as a group, then that evolved understanding has changed where we as a collaborative group are. I think the same is true for the Forest Service. Even though the agency has a bunch of experts in it, they're still just people and can learn by experience. And I think that over the years, our Forest Service partners have also learned some things, just like we as lay people have learned some things. And I certainly expect the Forest Service to continue to learn and to adapt. It would be a shame if we did all of this science and all of this learning together and then the Forest Service just decided, nope, we're going to ignore all that and do something else. I don't think that's going to happen. I don't expect that to happen. I do expect the agency to continue to be a good partner with us and to learn and to change based on what we've learned.
Would anyone else on the panel like to add to that?
I could add a quick note. I just actually blinked out and just came back up again, so I missed the tail of what SJ was saying. But I think my interpretation of that in the early stages of our collaborative efforts, it was probably very easy for the Forest Service to implement what we were asking of them, because it was fairly simple stuff. As we have evolved and over the years, it's getting much more difficult. And so, you know, people being resistant to change as people are, I would say now our expectations are potentially higher than what is actually being transcribed into the field for actual treatments. It's also very difficult to turn our zones of agreement into specifications for operators to follow in the field. And so there's sort of a disconnect, not a full disconnect there, but there's work to be done to make that a smoother process. And essentially, yeah, I don't think it.
Sorry, Dave. You there.
Really hitting the mark where we'd like to be today. So we're probably, as a collaborative, asking for. Fading out again. My internet's not great today, or unstable as it's telling me.
Yeah, sorry, Dave, you cut out there. Would any other panelists like to add to that?
That's my internet is unstable and kind of now.
I'll just say something very briefly and simple. As an example of the adaptive management for the collaborative, the enviros and industry were both committed to healthy forest, no doubt about it. But what each one understood by healthy was different, and that's part of the context and the claim and the challenge. Similarly, if you put healthy in the context of what the Forest Service is obligated by their policies, procedures, administrative choices, and other things to implement, it's yet a different notion. And that's how science, in both the data-driven and the observational qualitative effort, have informed our respective views of what healthy amounts to for the landscape that we're working on. And it has helped us to change how we approach our work, how we attempt to view the landscape. And the Forest Service, I think, is doing the same thing. The challenge becomes that the older plans just aren't up to date and don't allow them the same latitude that we can come to agreement about. And that's where we try to help, I think, enable changes, support changes, and provide cover for them.
So we have a couple more questions here, and then we're going to have final thoughts from the panel. And then if folks want to stay after that, we will, part of what S&W is doing is opening up the group to chat rooms. Our numbers might be small enough that we could be one group, but just allow everyone to put their cameras on and talk. So I'll open up the breakout rooms at the end of this. But just a couple of questions. Someone was saying that this is great information, and they wondered if there's a press release or a short public summary that's available for the monitoring that's happening, or reports from what you've been doing.
Not that there are reports and publications and so forth. I'm not aware of any press releases per se. I would direct you to our multi-party monitoring link on the BMFP webpage, which I think should be pretty easy to find. Google Blue Mountains Forest Partners, and there's a multi-party monitoring link there. And I shared my email with the group, and by all means, please contact me anytime.
Great.
Yeah.
Oh,
One little I would add to that, like James, I'm not aware of any official write-up of this, but we do get together every fall, and well, 2020 being an exception, but we do get together every fall and actually have a conference where we go over the results and look at a lot of new science. So if people want to continue to follow, that's a good thing to keep in mind.
Great, thank you. And I think this is one that you guys have addressed directly, so this will be good. And how do you avoid the problem of dueling scientists and along with or separate from the dueling science? And do you feel like you're helping address that by focusing on a specific place with your own specific data collection?
I'm not sure that I'm aware of an example of dueling science that's particularly salient. Perhaps I'm mistaken.
I think maybe an example would be that you guys hosted a workshop where some of the groups that left wanted to bring in scientists that supported their views. I believe it was around riparian management. Yeah. So I think that would be the example of dueling scientists, where scientists just disagreed with each other about what the best available science is and should be.
I think SJ or Pam should address that myself.
Yeah, I can take a swing at that first. You know, I think there's, I think it's important to remember that science doesn't tell you what to do. It just tells you some information, and then people get to decide what they want to do with that information. And there are certainly ways to evaluate the veracity of any particular data point that is offered in support or opposition to anything. For us at BMFP, we do spend a lot of time talking to well-respected experts in various ecological fields. And most of those folks, if not all of them, have done original research in the Blue Mountains in these ecosystems that we are working in. And those kinds of folks, their scientific opinions and conclusions carry more weight than others who may be conducting research outside of this ecosystem, or it's clear that they've got an acknowledged bias in their research and their objectives. And so for us, you know, things that are replicatable, things that have been peer reviewed, things that are ecological concepts that have been well accepted for a very long time, decades, those kinds of, that kind of science is what we tend to rely on in our work. And some of our zones of agreement, for example, our terrestrial upland zones of agreement, we've actually looked at additional or other science that is out there that may draw a contrary conclusion to the overwhelming majority of the literature. And we note that there is a difference of opinion. But it is a minority opinion, and it is one that is not really held up well at all in peer review. And so that's a data point for us. And we acknowledge that there's differences of opinion out there, but we're going to rely on the science that is well-established, peer-reviewed, replicatable, monitorable. And that's kind of where we've decided to put our emphasis.
Yeah, and I would just add that the local component, I think, is absolutely critical. It really, the site-specific scientific efforts in monitoring forest or region-wide are pretty critical. And it's one thing we've asked scientists to do is to address specific issues. For example, around post-fire harvest and impacts to woodpeckers, different species. And getting that local, rigorous information is pretty critical to moving public land management ahead for our particular locale. So.
Pam, did you want to add to that?
SJ and Mark really nailed what I was going to say. The only thing I can add on is just that, you know, there have been you know, there have been some critiques that, you know, oh, you're just looking at, you know, your favorite science. But I've got to say, you know, like SJ pointed out in our last set of zones of agreement, James did the hard work at that point in time of going through and looking at the strongest critiques and identifying, you know, really what they were and where they stood out, you know, differently than what we, you know, the narrative that we were understanding. And, you know, and we tried to really explain why we felt that the evidence really fell in the direction that we have gone. And, you know, I think perhaps one of the advantages we might have on this particular collaborative is having a couple of attorneys around who are really like into parsing like fine details. Hazard of the profession, but perhaps one that turns out to be useful in this particular situation. I think there's a number of papers out there that come to different conclusions, but if you look carefully at them, they often look at such enormous ecoregions that the specific local data gets washed out. And I think so it's important to just, you know, really drill down into the details of the science that you're looking at to understand. And that's why we've come to the conclusions that we've come to.
Yeah, and I might just add real quickly after listening to Pam, I think one thing that's critical for us is that our collaborative is well representative of the various stakeholder groups, so environmentalist or conservationist or industry and so on. And that's important because you might have the right scientific perspective, but if you're industry and it supports your view, people are going to challenge you. But when you have multiple parties that you would expect to be challenging one another, that come to agreement around challenging issues, there's a level of credibility and convergence there that I think supports our commitment to go forward. So I do think that representative character is really important to supporting the credibility of the perspectives that are out there that are frequently challenged.
I would just add a couple of things as someone who served as a science advisor to BMFP and to other collaboratives and Forest Service units. Not everybody's going to be able to get the level of funding of CFLRP and monitoring. But I would say that if you have the opportunity to hire James or someone like James to do the research, it pays for itself in dividends. Secondly, part of adaptive management and monitoring is you take what you believe is the best available science, and then you monitor it to see if it really worked on your landscape. So you pick a similar landscape, maybe don't borrow from the Tahoe Basin, you borrow from a nearby forest that's more like yours, but still monitor to make sure it worked and then adapt. And then on the dueling science and dueling scientists, my advice is that you should avoid dueling scientists, because then you're just pitting people against each other and they're having to defend their work and their career, and nowhere in there is there room to inform the collaborative conversation. And you should only have guest speakers who are going to inform the collaborative conversation. And dueling science is fine, but that should play out in the journals and not in a room in front of the collaborative. That the collaborative and your goals should be paramount, and not just having people who disagree with each other get in front of you. There's plenty of reality TV if you want that out there. So this question may actually be for both the collaborative and the Malheur or other Forest Service folks on the call here, but someone's wondering, is there going to be a collaborative 2.0 or 3.0 for the Forest Service? Or is there going to be a new iteration of what collaboration looks like?
I want to confirm if I saw Nick's name on with Forest Service. I think Nick is one we should talk to about that.
Hi, Mark. Kyle. I am here, but I'm multitasking a little bit, so I may have missed the call to question there.
Sure, Nick. The question is there going to be a 2.0 or 3.0 version of collaboration? with all that's been changing, and how would the Forest Service see that differently than where collaboration started?
Oh, that's a nice, tidy question. I'll say I hope so. I mean, you know, each new sort of development in the story of collaboration in the Pacific Northwest builds on the last. And there's certainly been a lot happening over the last 5 years that's affected the way community members are able to come to the table and collaborate with one another. There's collaboration happening at a somewhat of a different scale around plan revision in the Blue Mountains. And I expect, you know, those relationships that we've built through that effort, the Blue Mountains, Blues Intergovernmental Council that I'm referencing, I expect those relationships will carry forward and pay dividends in terms of how we work with community members on these landscapes, certainly. What that will look like, what collaboration 3.0 in this region will look and feel like, that's a tough question for me to answer at this stage. I'd be speculating, but a heavy emphasis on the monitoring piece and bringing multi-party data, local monitoring data to the table to pair with, validate and/or challenge some of the broad scale monitoring data that we look at regularly and will continue to. I think that's got to be a part of it.
Great.
That answer was somewhat on point.
Thank you for being on call. Yeah, I would offer from Sustainable Northwest perspective, collaboration has shifted, I think, already twice, in that originally the parties that used to disagree with each other, except that they hated the Forest Service, got together, and that was primarily industry and conservation. It also included county commissioners and some local citizens or industry partners. I think the difference is now there's collaboration all over on many landscapes, and not everybody can come to all the meetings, and not everybody chooses to come to all the meetings. Originally, if the collaborative agreed and the Forest Service did that, there was no objection litigation, but those days are gone. There's almost objection on every project, on every landscape, and that's because you can object from, if you're a US citizen, you can object anywhere. So groups from out of state are objecting, and groups that left the collaborative table are objecting. And that shifted the dynamics once, and I believe it's shifting it again, in that the Forest Service now counts on the collaborative to help them understand what perspectives to include that aren't at the collaborative table, and the difference between a legal comment for objection versus what the social values really are behind that legal comment.
Yeah, that's a good point, Trent. And if I might just build a little bit on what I said previously, just want to draw attention to the adaptive management work group that we're trying to stand up as part of the 21-inch amendment that we executed recently. And that plays into exactly what you're talking about, relying on what collaborators are seeing locally to help inform whether we need to make another turn in terms of management direction for large trees in the eastern part of the Cascades in this region. So just a plug that you'll be hearing, seeing more coming out soon about that, but that we really value and need participation from local stakeholders who know these areas and are observing in real time those changes on the landscape. So more to come on that. I think we should have our first, just a preliminary meeting to sort of share some of the strategy for how that work group will come together and proceed once we have actual data to look at in the fall of this year.
Great, thank you, Nick. So we're coming up on the 15 minutes left. I'd like to offer to create a couple breakout rooms, just so we're in smaller groups, for those of you who want to stay, and that everyone can turn their cameras on and have a conversation. So I'll create three breakout rooms. We can have 5 people each, so everyone has the opportunity to talk. And I'll just ask that maybe the panelists spread themselves out into those break rooms. And then I will let participants choose. So if you go down to the breakout room button at the bottom of your screen, if you click on that, you'll see that there's 3 breakout rooms, and you can, did I do it? Okay, can you see those? Are they showing up?
All
Okay.
right, just so BMFP folks know, I'm going to room 1.
So feel free to turn on your cameras and unmute yourself and join a conversation and be able to talk in person if you'd like. So you should join the rooms, and I'll stay here in the main breakout room.
Trent, I am not seeing a choice to actually go into another breakout room. I see that there are breakout rooms, and that's great information, but I don't have enough to get into.
That's fine, Pam. I'll send you to one. Here you go.
Perfect, thanks.
Could you send me to one too? It doesn't seem to be working when I'm clicking.
Yes.
Thank you.
Happy to do that.
And me, please.
And James.
Okay. Anybody else having trouble or want me to help them find a room?